1943. A drawing office in Leyland, Lancashire. Outside, the factory floor is producing Cromwell tanks and aircraft engines in shifts that never stop. Inside, a small team of engineers is working on something quieter, something slower, something without armour, without guns, without the roar of a Merlin engine overhead. They are designing a truck, not just any truck, the largest, heaviest, most capable cargo lorry Britain had ever built for military service. A vehicle designed to carry 10 long tons across roads that had been bombed, bridged, flooded, and frozen solid. A vehicle designed to keep the guns fed when the army outran every railway line in Western Europe. It looked unremarkable. A tall steel cab above a long flat bed. 6 wheels turning on 2 driven rear axles. No armour, no turret, nothing dramatic to see. It looked, to most observers, like an ordinary lorry. It would go on to supply the advance from Normandy to the German frontier, carry fuel to RAF air bases through 2 decades of post-war service, haul loads that would snap the axles of every lighter vehicle in the fleet, and remain in British military use for nearly 40 years. Its name was the Leyland Hippo Mark II, and it was the most powerful general service truck Britain produced in the Second World War. To understand why the Hippo Mark II existed, you need to understand the problem Britain faced in 1943. The standard truck in the British Army was the Bedford 3-tonner. It was reliable, light, and available in vast numbers. It was also, for the logisticians planning the invasion of Europe, completely insufficient on its own. A single division consumed roughly 750 tons of supplies every day during active operations. Ammunition, fuel, rations, engineering stores, bridge panels, artillery ammunition. Every 25-pounder field gun battery fired shells by the thousand. Every Bailey Bridge crossing consumed hundreds of individual steel panels, each weighing 570 pounds. None of it moved by itself. To move 100 tons of ammunition by 3-ton lorry required more than 30 separate vehicle journeys, 30 drivers, 30 fuel stops, 30 breakdowns spread across roads already crowded with armour and infantry. The arithmetic pointed clearly to a different answer. A 10-ton truck carrying the same load required only 1/3 of the vehicles, 1/3 of the fuel, 1/3 of the drivers. It could cover 2 or 3 times the distance on a single tank. It could reach depots that 3-tonners would need 2 days to empty. The War Office drew up the requirement in 1943. Leyland Motors, already building tanks and tank engines in Lancashire, turned to the task of designing a truck that met it from first principles. This was the critical difference between the Hippo Mark II and every other 10-ton truck in the British fleet. The Foden and the Albion that filled the same tonnage class were both adapted commercial chassis, civilian designs fitted with military cabs and WD bodies. The Hippo Mark II was designed as a military vehicle from the outset. Every feature was a deliberate answer to a military problem. The engine was a Leyland Type L, a 6-cylinder inline diesel displacing 7.4 litres and producing 100 brake horsepower at 1800 revolutions per minute. Leyland manufactured not only the engine block but its own fuel injection equipment. The company built the precision machinery to drill its own injector nozzle holes, a detail that mattered because diesel injection tolerances are measured in thousandths of an inch. A faulty injector means a dead engine. A dead engine means a convoy that stops. Power reached the 2 rear-driven axles through a 5-speed main gearbox paired with a 2-speed auxiliary, giving 10 forward ratios in total. The auxiliary added a multiplication factor of 2.2 to every main ratio. A contemporary road test from June 1945 noted that on rolling Lancashire terrain, the low auxiliary range was almost never needed. Second gear could hold 5 miles per hour on a gradient of 1 in 6. The truck pulled with confidence well below its limits. The drivetrain was 6x4, 6 wheels, 4 driven, 2 steering. The configuration gave traction and load distribution, without the complexity of a driven front axle. The cab was enclosed steel, with pull-down windows, a heater, and a removable upper section. The upper section removal reduced total height for shipping. The cab roof could be lifted off in minutes. Sling rings mounted on each wheel hub provided crane attachment for loading aboard transport vessels. These were not civilian conveniences. They were features that answered the specific problem of how to put a 19-ton loaded lorry inside a cargo ship. The body was a well-typed design, meaning the load floor sat lower than the top of the wheel arches. This lowered the centre of gravity and, more practically, reduced the height that a man had to lift a shell case or an ammunition box before it cleared the tailgate. Everything loaded by hand. Every inch of height saved was another day of drivers who could still use their arms. Unladen, the Hippo Mark II weighed approximately 8 1/3 long tons. Loaded to its 10-ton military rating, it grossed close to 19 tons. Its fuel tanks held 90 imperial gallons. At 8 to 9 miles per gallon, that gave a range of roughly 700 miles. 700 miles from the Normandy beaches took a convoy past Brussels, past Eindhoven, toward the German frontier itself. That was the point. That was exactly the point. Now, before this vehicle takes to the road, if you are finding value in this deep look at the machines that kept the British Army moving, hit subscribe. It takes 1 second, costs nothing, and allows the channel to keep producing work like this. June 1944. The first Hippo Mark IIs were still months away from entering service. On the beaches of Normandy, the army that would eventually need them was already fighting for its life. What followed over the next 3 months would create the exact conditions the Hippo had been designed for. By late July 1944, 690,000 tons of stores had been landed in Normandy. Nearly 200 bridges had been destroyed across the Calvados region alone. The Germans had blown every road node, every railway junction, and every bridge across the Seine Valley before the campaign began. The Bocage countryside channeled vehicles into narrow sunken lanes. The roads had not been maintained through 4 years of occupation and were now carrying weights they were never rated for. The American Red Ball Express launched on 25th of August 1944. Over 6,000 trucks, primarily the American GMC 2.5-ton 6x6, ran one-way circuits from Normandy toward the front, delivering 412,000 tons of supplies over 83 days. The British equivalent, the Red Lion Express, ran from 16th September to 12th October, along a 300-mile route from Bayeux to Brussels. It exceeded its target of 500 tons per day, averaging 650 tons daily. But the crisis was not over when those routes closed. Antwerp had been captured on 4th September 1944, but the Scheldt estuary remained in German hands until late November. The port was useless until the estuary was cleared. Supply lines remained over 300 miles long. Road transport carried virtually everything. By this point, the Hippo Mark II was beginning to arrive in the rear areas of the British Second Army. The Royal Army Service Corps, the largest single corps in 21st Army Group, was the primary operator. Its heavy vehicle companies handled the long-distance runs, the ammunition resupply to corps-level dumps, the fuel runs that kept the armoured divisions moving. The load categories that fell to the 10-ton class were exactly those that lighter vehicles handled worst. Bailey Bridge panels by the 100, each requiring careful stacking. Complete engines and gearboxes for field workshops. Reserve fuel in bulk containers. Ammunition for medium artillery. The 5.5-inch guns that fired shells too heavy for a man to carry without a mechanical aid. Every one of those loads moved in a single Hippo journey that would have required 3 or more Bedford journeys across roads that were already at their limit. The winter of 1944 to 1945 added another variable. Operation Veritable, the assault through the Reichswald toward the Rhine. Launched in February 1945 across ground deliberately flooded by German engineers who had opened the Ruhr dams. The routes were not roads. They were corridors of mud and standing water, rated by bridge classification, and passable only to vehicles whose gross weight could be matched to the engineering of each crossing. A Hippo at 19 tons gross required a Bailey Bridge rated Class 20 or above. The engineers built them. The Hippos crossed them. In March 1945, Operation Plunder put the Second Army across the Rhine. The advance from the Rhine to the Elbe that followed covered more than 200 miles in under 3 weeks. There was no railway support. The entire advance ran on road transport alone. The Hippos were among the vehicles that made it possible. A specific documented detail records that the specialist reference on British military transport describes the 10-ton class as, quote, particularly valuable after the breakout from Normandy when the advance to the Belgian and Dutch frontier was almost entirely dependent on road transport. That assessment was made by the men who supplied the army. They knew which vehicles could do the work and which ones could not. The Hippo Mark II could. The Hippo Mark II was not the only 10-ton truck in the British fleet. The Foden used a Gardner 6LW diesel producing 102 brake horsepower. The Albion used a 9.1-litre diesel rated at 100 horsepower. Both carried the same 10-ton payload on the same 6x4 configuration. Both were competent vehicles, but both were adapted civilian designs. The Foden's commercial heritage was visible in its cab architecture and its drivetrain layout, both optimized for peacetime road haulage rather than military loading. The Albion had served in North Africa from 1941 onward, a year before the Hippo Mark II existed, and had proved the concept. The Hippo Mark II answered the same requirement with a vehicle built from the beginning to ship, load, drive, and maintain in a military context. The American Mackinac was produced in over 16,000 units and served British forces under Lend-Lease. It produced 131 horsepower and was heavier unladen. It dwarfed British 10-ton production by a factor of more than 15 to 1. The Americans built at scale that British manufacturers could not match. Germany had no mass-produced equivalent. The heaviest standard German military trucks of the war, the Boessingnay G 4500 and the Mercedes L 4500, both topped out at roughly 4.5 tons of payload, less than half the Hippo's capacity. Germany relied on railways and horse-drawn transport in ways that the British and Americans had abandoned. That reliance became a catastrophic vulnerability when Allied air power and sabotage destroyed the rail network behind German lines. The Wehrmacht could not easily substitute trucks for trains. The British Army could substitute 10-ton trucks for 3-tonners whenever the road permitted it. The Hippo was retired from the British Army's frontline fleet in the 1950s. The Royal Air Force held on far longer. Converted to carry 2,000 Imperial gallon fuel tanks, Hippos served as aircraft refuelers at RAF stations through the 1960s. A 1962 War Office user handbook covering the Mark II, the Mark II-A, and the Mark II-B confirms that the type was still considered current enough to require official documentation 18 years after its introduction. The last known military servicing stencil recorded on a surviving example is dated October 1981, 38 years of military service from a truck designed in 1943. 1943, a drawing office in Leyland, Lancashire. A small team of engineers working on a truck. The Hippo Mark II had no armour. It could not cross rough country. Its top speed was 30 miles per hour on a good road, and considerably less on the kind of roads it was most often asked to use. It had no power steering, and drivers who spent a full day at the wheel arrived exhausted from wrestling a 19-ton load through corners designed for horse carts. It had over 100 grease nipples requiring service after every trip. It arrived too late for D-Day, too late for the initial battles in the Bocage, too late for the summer of 1944, and yet it worked. In the mud west of the Rhine, in the flooded ground of Operation Veritable, in the 300-mile supply corridors that kept the Second Army moving after every railway had been cut, on RAF airfields through 20 years of peacetime service. Fewer than 10 restored examples attend military vehicle rallies in Britain today. The Imperial War Museum holds one. Its service record is listed as unknown, but the loads it carried were real. The roads it held together were real. The guns it kept fed were real. That is not luck. That is British heavy engineering doing exactly what it was designed to do.